Controller modes and program files. Okay, this is where we were at the last session, and we were uploading, downloading, and we were doing more comparisons between the offline data file and the online data file. Really, if you get all this basic stuff down pat, your whole career is going to be really going to move along more smoothly. Now, you would learn all this anyway, but you would learn it the hard way out there on the shop floor. So take advantage and learn it right here, right now. Now, we had a little real quick change in the appearance of RSLogix. Wasn't even a whole page. So you go to anywhere in the open space, right click properties, and you can go in and change everything. I mean, address display, you can go to single line, split line. Watch right here, B3:0/0. I'm going to go to split line. Hit apply. See, it drops the bit down below. What I don't like about that is it takes up more vertical space on the screen and you can't see as much logic. We'll flip it back. You can also change it from word bit to bit. So check this out. Now it's just B3/0, but guess what? I'll go show this. What the heck? I'll change this to B3023. I'm going to undo this, but what I wanted to show you was you could display it like that, or go to properties, address display, go back to word bit. Now watch right here. And the B files are the only ones you can do this with, and it works out good for the bit shift type instructions. But you can treat the whole B3 file as one continuous series of bits, 0 through whatever the last bit of the highest word. So I'm going to hit apply. See, that's actually B363/15. And it'll go as high as 4096. So you could have B3 255/15. Well, let's do that. B3, change that to 255. Now you might be thinking that we don't have that many words in our B3 file. Well, if you do something like you're looking at right here, offline, it will create it for you. So when I will open this puppy up, see I've got 3 words, right? And we'll lock this on top so you can get the full effect. Now when I verify this, watch what happens here. It created that, it maximized the array out to its full 256 complement of elements of 16-bit integers. Okay, and this bit right here is 255/15 is the highest bit in the maxed out B3 file. I'm going to pull this back up here. I'm going to go back to properties, and I'm going to go to address display, and I'm going to go back to right here, apply. See, B3/4095, which means the maximum number of bits that you can have in any data file like a B3 or an N7 is 4096, 0 through 4095. Now I'm going to change it back to the word bit. So you could have done the same thing with the IO, which I accidentally did. And it gets rid of the .0. Some people like that better. See? So it's the O or output file, word 0, bit 0, instead of slot 0, word 0, bit 0. And what you don't realize is, I'm going to leave it this way because that's more correct. Okay, we're back to the way I like it. What you don't realize is that each slot in the I/O chassis, we'll call it the RSLogix 500 arena or venue, can handle, or it's possible to have up to 32 words of input and 32 words of output data from one slot. Now we're not going to cover any modules like that, but that's why it pops up and shows slot, word, bit. This 1400 does not have any of that. Okay, But it is possible to add a module that does, like the analog modules. Well, they have more than one word per slot, input and output. Okay, enough of that. Online modes and the online data files. So we're beating this to death for good reason. So first we had to go back online. And I'm going to say no, we don't want to save any changes, because remember, I went off chasing rabbits when I was talking about changing the looks of our screen here. So then I had to go to the program mode. Several ways to do that. It's okay to do it from here because it has nothing to do with the driver. You're already online. You're just switching between run and program. While watching the logic and the states of the memory locations that they address, toggle on the first switch on your field device simulator. So right there, you're looking, the switch is off. Toggle it on. Does anything happen? Nothing happened because you're in the program mode. You're not scanning the input. So the switch is still on. Let's switch to the run mode. Then something does happen. As soon as it updates the input image in the data table, then the first rung of logic says, hey, I:0.0/0. Are you on? Yes, I am. Okay, then I'm true. And it says, hey, B300, you're on. Next rung, hey, B300, are you on? You are? Good, I'm true. Hey, output 00, you're on. That's a little bit of a stupid, corny way of doing the code, but you get the drift, right? Okay, so, in the remote run mode, flip on the input, did anything change? No. While watching the logic and the states of the memory locations that they address, switch the mode back to remote run. Did anything change? Yes, it did. Is the light lit on your simulator? Now, if you're using my simulator, it'd be the red light at the top. Yes, it's lit. List as many things as you can see that changed when you return to the remote run mode. All the true, if, whatever instructions are now true. The rungs are true, and the bits are on. Did the values in the data table change state? Yes, they did. Why? Because the logic executed. It read the inputs, that input was on, it turned on a bit, and that bit being on in the second rung turned on the light. Okay, then I had to go to this instruction right here and do a toggle bit. Okay, so watch the instruction. I had to toggle it. Did the state of the bit that you toggled appear to change? No, the reason I put in the word appear is because actually it did, because during the execution, it turned off that bit, but then the controller turned it right back on with the input scan. You'd never see it go off. So it does not appear to change. The answer would be no. Repeat this action on each of the memory locations addressed by the four instructions. Did the state of the bits that you toggled appear to change? So we'll try this one. Toggle. Actually did, but you're not going to see it. This is the same bit. Toggle it. This one. Toggle it. You're not going to see it because the program runs 1,000 times a second. If we go to processor status and go to scan times, you'll see that the last 100 microseconds scan is vacillating between 2 and 3. So we can clear these by selecting putting in a 0. Whoops, we don't want that. I didn't mean to change that. Okay, that's the watchdog timer. You don't want to mess with that. 10 times 10 milliseconds, that's 1,000 milliseconds. The watchdog timer, if it sees the program is stuck in the program execution, not input output scan, but just the program execution, more than that length of time, then it faults. If I put this down to 1, I might get it to fault. But you see our scan time is around 3, 4, 5 times 100 microseconds. So that, we'll say it's 600 microseconds. So that means that this program is scanning over greater than 1,000 times a second. So even though I might get that to turn off in less than a thousandth of a second, it's going to turn it right back on. That's what we're demonstrating here. Repeat this action on all the other memory bits. Do they appear to change? No, they do not. Okay, then I had to go to the scan time. Look at the scan time, 500 microseconds. If the state of the bit did change and the logic changed it back, would you even see it? Well, that's, an answer on your part. You may want to say you did. You may want to say you didn't. I'm saying you didn't. Then I had you repeat that again on the switch after you went to the remote program mode. So let's go to the remote program mode. Now notice the bits stay in the same state. Now go here and toggle. And of course, did the state of the bit that you toggled change? Yes, it did. Repeat this action on each of the memory locations addressed by the 4 instructions. Did the state of the bits that you toggled change? So I'm going to do this one right here first. Toggle it. You can see that it changed. Now watch these two. It doesn't matter which one I toggle, because remember, it's the database that's animating this offline project. So we'll toggle that one. See, they both went off. This went false because that was off. I can toggle it off from here though, because I'm toggling that memory location on off, not the instruction true false. You cannot toggle the instructions true false. You can only toggle the state of the bits that they address. Then I had you open up those 3 files and lock them on top again. And you see I have them all kind of packed in here so you can still see the logic. You just have to know there's nothing in those 2 rungs that's being blocked by that data file 3 display. Then I had you right click and toggle those same bits from here. Toggle bit. See, I toggled in B30. Now it shows true and on. We'll toggle the output bit. Now watch your light. Right now the light is off, right? You toggled it on and it's still off. Why? Same reason that when we toggle this bit on, we see that this is all on, but our output light is not on because we're not running the program. So even though you've turned on and off bits in the program, that does not mean that they represent the input image or have been sent out to the output hardware. That's something very important to remember. We're doing all this for a specific reason. So we just toggled some bits. Did all of the bits change state and remain in the last toggle state? Yes, they did. The first switch should still be in the on position. While watching that bit, both in the logic and in the input data file display, flip it to the off position. So we're talking about in the input file, this bit right here. Okay, first switch. So I'm going to turn that off, and you see nothing changed. That's because we're not executing the executive code in that controller. It's in the program mode, not the run mode. If we went to the run mode, then that switch setting would be reflected in that first switch instruction, which would be false when we flipped it off. Did any of the displayed bits change with toggle of the switch? No. What does this tell you? This tells you that in the program mode, you can toggle bits on and off from your keyboard, but you basically have disabled the logic and you have disabled the entire scan. The project, program, whatever you want to call it, is not being scanned. So the input image is not being updated to match the state of the input field devices, and the state of the output bits are not being sent out to the hardware to turn those outputs on or off. With the first switch in the off position, switch the controller to the remote run mode. Now it says run mode in the book, but you've got it set to the remote mode, program or run. So we'll go to run mode. Now notice instantly all those bits went off. Well, these 2 went false and these 2 bits went off. Did any of the displayed bits change with when you went to the run mode? While watching the bit, both in logic and in the input data file display, flip input 0 to the on position. Okay, we'll flip it back on. They all changed. What does this tell you? That regardless of the state of what you see on the screen, the mode that it's in is the dominant force at work. If it's in the program mode, you can go in there and flip stuff around to your heart's content. But the moment you put it in the run mode, the actual field device states for the inputs take over and the logic takes over, and you can click and toggle all you want to no avail. Okay, next up, with an eye on the data file displays, flip the position of the switches connected to input 2 and 5 to the on position. So you're watching right here. 2, that's that bit right there. Now I'll highlight 5 this time. You can see it's 0 and 5. And your answer should have been yes to is this what you see. Try toggling from the keyboard, input 0 through 5, do they react? The answer should have been yes. With an eye on data file displays from the keyboard, toggle bits 0, 2, and 5 to the on state. Okay, so you're looking at your lights. I've got one light on right now, so I'm going to go and toggle that one on. And now I've got a green light on, and I think it was 5, toggle that. Now I got a blue light on. Is this what you see? The answer should be yes. Now, there was a question in there. If I flip on 0, 2, and 5 to the on state, will this change the state of output 0? No, it will not, because it does not affect the logic that is controlling output 0. Those things we turned on and off, none of them are used in the ladder logic. With an eye on the data file displays, toggle the switch connected to input 0 to the off state. Now we already know what it's going to do, but just do it anyway. We toggled these on, and that was cool. Toggle this one off. And of course, you're not going to see anything happen, because the I/O and program scan rules this kingdom of bits, period. The controller's in the program mode. The logic cannot change the state of any bit in the controller's memory, but any external device, like your computer or an HMI, can change if it has established communications with the controller and has an interface to do it. So in other words, if you're connected up with an HMI or a laptop, you can, from those external devices, move the bits around. If the controller's in the run mode, all the above is true, and the executing program files can change the state of any bits of memory that the commanded instructions are addressing. If you have any bits on that are not in the logic, it's because I had you toggle them on and never had you toggle them off. This is an important characteristic of the controller's data table. If your logic turns on a bit and no one turns it off, it will stay on forever. You can double click on the output file and change any of those bits that are 1 to a 0. All inputs off before you proceed. Okay, I got all the inputs off, which you can see right here. Okay, so that turns all this stuff off, but guess what? I've still got some outputs on. I would, if you don't turn them off, then you'll see them pop up later. So these lights are going to stay on anytime this thing's in the run mode, because there's nothing to tell them to go off. So I'm going to select each one, 0, enter, 0, enter. The only reason I'm doing that is so I don't have to explain to you later why those lights are still on. That's the last thing they heard. Hey, you're on. They heard it from your keyboard.